Hi everyone, I am Bhavna, 4th semester, Electronics and Communication Department of Sri Venkateshwara College of Engineering. Today, let us deal with the subject mathematics. In that, let us deal with the topic application to oscillation of spring and LCR circuits in ECE stream. Agenda of this topics are key topics discussed in this presentation are simulation and modeling, game development, control systems, signal processing, analog electronics, Internet of Things, and circuit design and analysis. So those were the main agendas of this particular topic. Introduction of this particular topic is in electronics and communication stream, the application of oscillation in spring and LCR are more theoretical and have connections to specific areas of study. Here are some example of how these concepts might be relevant in ECE stream. First and the foremost thing is, let us learn and understand the topic, that is oscillation in a spring and LCR circuit. In ECE stream, LCR circuits in electronics and signal processing, engineers working on digital signal processing, that is DSP, and LCR circuits, resonant properties to design filters for the applications like audio processing, image processing, and communication systems, understanding resonant and oscillation in LCR circuit help in developing efficient filtering technique and frequency analysis tools. Moreover, the study of LCR circuits can be relevant in embedded systems and hardware designs. Engineers working on microcontrollers and electronic circuits might leakage this knowledge to build and analyze oscillators, frequency generators, and communication modules. So this is the meaning, and this is actually the introduction of the topic oscillation in a spring and LCR circuit. Now let us learn the agendas of the applications of oscillations of spring and LCR circuit, how it has been implemented in ECE stream. The first and the foremost agenda is simulation and modeling. ECE students often deal with simulation and modeling tasks such as creating realistic physics-based animations or simulating real-world systems. Understanding the oscillation of spring and LCR circuits can be useful for simulating mechanical systems and electronic circuit accurately. So, this is the first agenda which deal with the applications of spring and LCR circuit in ECE stream. So, the first agenda is simulation and modeling. The second agenda is game development. In the context of game development, physics engines are special to simulate the realistic movement and interactions. Spring and oscillations are fundamental concept used to model motion and collisions in games. Integrating these principles into game physics engines can lead to more realistic and immersive gaming experiences. So this is the second agenda which deal with the applications of oscillations of LCR circuits and spring in ECE stream. So the second agenda is game development. Let us learn about the third agenda, which is control systems. Control systems are an integral part of modern engineers, and EC students may encounter control theory in robotic, automation, and even software systems. Oscillations of spring and resonant in LCR circuit can be relevant in understanding and designing the control system for physical and electronic applications. So this is the third agenda which deal with the oscillations of spring and LCR circuit in EC stream. So this is the third agenda, which is nothing but control systems. Now let us learn the fourth agenda. The fourth agenda of this topic is signal processing. LCR circuits are commonly used in electronics for filtering and signal processing tasks. In ECE, understanding the behavior of LCR circuit can help in designing and implementing filters for various applications such as audio processing and image filtering. So this is one of the fourth agenda which deal with the applications of LCR circuit. That is nothing but the oscillations of spring and LCR circuit in ECE stream. So the fourth agenda is signal processing. Now let us learn the fifth agenda is analog electronics, which is one of the most important one. While EC focus more on both software and the digital systems, some programs may include the courses on analog electronics. Knowledge of LCR circuit and the oscillations of spring can be useful in understanding the behavior of analog circuits and component, which is the fifth agenda of this particular topic of oscillations and the applications of oscillations of spring and LCR circuit in EC stream. This is how it has been implemented. So the fifth agenda is analog electronics, which is one of the most important one. The sixth agenda is Internet of Things, that is nothing but IoT. In IoT project where sensors and actuators are involved, the understanding of oscillatory behavior can be relevant. For instance, in certain IoT applications, spring-based sensors might be useful to measure certain physical parameters. So it is a sixth agenda which is implemented and which tells us about the applications of the oscillations of spring and LCR circuit in EC stream. So the sixth agenda is Internet of Things. Let us learn the last agenda of this topic is circuit design and analysis. It is one of the last agenda, which is one of the most important agenda of this topic. Although ECE primary deals with both the software development as well as our development, some program may include the courses on hardware design and embedded systems too. Knowledge of LCR circuits can be beneficial for understanding the analog circuit behavior and designing the circuits for specific applications. This is the last seventh agenda which deal with the applications of oscillations of LCR circuit and spring in EC stream. This is how all the seven agenda helps us in understanding the applications of the oscillations of LCR circuit and springs in EC stream. These are the seven most important agendas which actually understands the topic of the LCR circuit and its applications and how it has been implemented in EC stream. So thank you all for the session. Thank you.